First of all, I want to thank you. Thank you for staying for so long and for my talk. I hope I will not bore you in these next 25 or 30 minutes. So basically, blockchains are highly, you can say, debatable in nature these days, and then there is no single way of putting this technology forward. There are so many versions, there are so many platforms, there's just so much going on in this space. And I thought I should just talk about why the diversity is important, why there are different kind of blockchains needed, and how do they solve different kind of problems. So that is the talk, what is going to be about. And a little bit about me. My name is Gautam Dhameja. I'm a solutions director with Parity Technologies, primarily building the Polkadot platform. So let's get started. What I'm going to cover in these next few minutes is basically three things. First of all, we want to understand from the grounds up what is a blockchain, like how does it function, what is inside it, and so on. Based on that initial analysis, we will see how these things can be different for different kind of use cases, hence putting us in a spot where we need different kind of blockchains. And finally, to connect that all, we will see how to build these different blockchains, because of course, when you need them, you need to build them. So let's get started. On a very basic level, on the most you can say fundamental level, blockchain is just a collection of nodes. It's a peer-to-peer network of nodes that allows you to build decentralized applications on top of a network. How it works is simply, all of these nodes process transactions, they create blocks, and these blocks update the state of the blockchain based on consensus. There are so many, you can say, key terms in this last statement that I said, and I will break that down very, very, like fundamentally in the next slide. So what I want to talk about here is anatomy of a blockchain, what happens inside a blockchain node. Let's do a double click. In a single blockchain node, there are these kind of different components in general. First of all, because blockchain stores the state, so you need the storage network or the storage component of a blockchain. The second most important component is networking, because all of these nodes are connected to each other. If they don't have networking, they won't be able to create a network. The third one is basically a transaction queue. When the user submits a transaction, it needs to be validated. It needs to be checked for correctness. And it stays in a queue before it becomes part of the consensus. So that is where you have the transaction queue. Then you have a node RPC. Basically, every node, every blockchain node has some sort of an RPC or an API available as part of it so that the user can interact with the node. If you don't have this, the user will not be able to interact, and then the blockchain is useless. So you have an RPC. But the most important of them all, essentially, is consensus. When you are storing some state, you want all of these nodes to agree on that state. And that is where the consensus mechanism comes into the picture. And finally, last but not the least, which makes everything very different, is the state transition function. What the state transition function is just the business logic of your blockchain. Now, let's take an example and see what does this even mean. So when I say state transition function and the business logic of a blockchain, what it means is it verifies and executes the transactions sent by the user. Once those transactions are enough available, they are then processed into a block, or they are collected into a block. And finally, based on the consensus on these blocks, the state of the blockchain is updated. All of this, all three of these things happen as part of the business logic of your blockchain, which is the state transition function. Now, let's take an example, or let's take two examples. You must have heard about these two things, Bitcoin and Ethereum, yes? What happens inside the Bitcoin state transition function? It simply allows you to do a peer-to-peer transfer of Bitcoins. That is the state transition function of Bitcoin blockchain, nothing else. And what happens in Ethereum? It does one more thing. It allows you to also deploy smart contracts and execute them, which makes all the difference. When you are building a blockchain and you want to build an application on top of it, you need some sort of business logic to run as part of that application. And there is some business logic that runs in your client side and the rest of the business logic that runs on your blockchain. And that is where smart contracts come into the picture. So what Ethereum state transition function allows you is to upload or deploy custom business logic as part of smart contracts. And that is where you can create applications. Now let's take a look how it works. Let's do a double click here as well. I should rather name this talk about double clicks, but anyway. So how do smart contracts work? Every blockchain node has a generalized execution environment. In the Ethereum blockchain, it is called EVM, Ethereum Virtual Machine. In some other blockchains, it is also utilizing a newer technology called WASM, WebAssembly. And there are a few other execution environments out there in the ecosystem right now. So the blockchains have this generalized execution environment. They have their own rules to process the smart contract logic. And then, on top of this, you can deploy your smart contracts. So these smart contracts can be for different kind of applications. And that is why I have put these boxes in different colors on this slide. So one smart contract can be about supply chain, the other can be about gaming, the third one can be about payments, and so on. So different kind of applications running on the same blockchain with the same generalized execution environment. Isn't that cool? Well, not so much. So let's look at some of the problems with this thing. When you are building a different kind of applications on the same blockchain, what happens is different applications require different kind of optimizations. Let me give you some examples. So gaming, when you are building a gaming blockchain, or when you are building an application that allows you to do some gaming on top of a blockchain, you need a different kind of throughput from the blockchain. You cannot survive with generalized throughput. You need optimizations. When you are doing a payment processing blockchain, you want to make sure that your transaction fee is as minimal as possible. You don't want to pay more transaction fee than the payment you are transferring. When you are building a supply chain blockchain, you want to make sure that you are doing all the different kind of calculations with utmost efficiency and throughput, and so on. NFTs, they require a different kind of processing, which sometimes requires to batch them all together and transfer them. So all of these different kind of use cases of a blockchain require you to do different kind of optimizations. But the problem is, there is single execution environment. How can you do different optimizations when you are not able to do that because everything is generalized? So that is the problem. This is the first problem I'm going to talk about, is different kind of blockchain use cases require different kind of optimizations, but the smart contract platforms treat everything the same. That is the first problem. Now, what do we do about it? What's the solution here? Custom blockchains? Now, before I go in deeper, what is a custom blockchain? Let me give you an example. So Bitcoin is customized or optimized for peer-to-peer transfer of money or Bitcoin. Similarly, Zcash is transferred for peer-to-peer transfer of Zcash, but in a more private manner. There are more blockchains of this kind which are fully optimized for their own use case and nothing else. There is a blockchain called Flow, which is only optimized for NFTs. So these are your custom blockchains. So when the smart contracts are not allowing you to do optimizations, then you go towards custom blockchains. How does it look like? When you build a custom blockchain to optimize for your use case, you can have a different kind of validations in your transaction queue. You can have a very, very well-optimized state transition function. You can put all the rules and logics and still keep it completely optimized for your use case. You can have different kind of consensus available. For example, in a supply chain blockchain, you might not need instant finality, but in a gaming blockchain or a payments blockchain, you need finality to happen instantly. How do you optimize it? You have to change the consensus mechanism. So a custom blockchain allows you to do all of this stuff. You can customize anything. But there is one more problem. It takes time. When you are building a custom blockchain from scratch, it takes a lot of time to figure out what is the best consensus that you can use, what is the best transaction queue logic you can use, and so on. It is a lot of effort that goes into building a custom blockchain if you are building it from scratch. Now, second problem. There is a compromise that we have to make. Either we do not have a lot of optimizations to do, which is the smart contract way. You can deploy everything very quickly, but you cannot optimize it. And the second one is you spend a lot of time, money, and effort to build a custom blockchain from scratch. So do you want to make a compromise with this thing? I don't think so. We should not be making any compromises. So what is the solution here? Substrate. So basically, we at Parity Technologies, we built a framework to basically create custom blockchains from scratch, which are faster to market, and they can, you can optimize it as much as you can for your use cases, for your applications, and for your users. So basically, a framework to build custom blockchains without any compromises. Now let me give you an example. When I say a framework to build custom blockchains, what does it even mean? Let me first give you an example of something that you already know. Some of you must be knowing about React. React is a framework that allows you to build custom web applications. What it already provides you is it has an application layout, it has a flow on how the components will interact with each other, it has some state management in it, it has some basic components built into it. So when you want to build your custom web app with React, most of the time, all you want to do is create your custom components, build them as part of your application, deploy it, and then your website or web app is ready. It allows you to build custom web applications very quickly, and that's a framework. Now, similarly, Substrate is a framework that allows you to build custom blockchains very quickly. It comes with inbuilt consensus engine. It comes with fully modular, all the validations that you can write. It comes with a WASM optimized state transition function. All you need to do is build your custom modules, which are called palettes in Substrate world. Build your palettes, and you can build a custom blockchain from scratch within a few minutes. That is where you don't have to spend a lot of time or effort, and you don't even have to compromise with the optimizations. So that is one part of it, where Substrate as a framework allows you to build different kind of blockchains very quickly. And because all of these different kind of use cases require you to have different kind of blockchains, we can safely say that the future is multi-chain. We will require all these different blockchains to work on different optimized use cases. Now, when we say the future is multi-chain, we see there are so many blockchains built for different kind of use cases. You have blockchains built for collectibles or NFTs. You have blockchains built for payments, which is Bitcoin. You have blockchains built for logistics, real estate, governance, DAOs, identity, and so on. There are all of these different kind of blockchains out there right now solving different kind of use cases. But there are so many blockchains. Another problem. How do we connect them all? So basically, when we say the future is multi-chain and there are so many blockchains, we need to make sure that they are all connected so they are not sitting in silos. And that is what the Polkadot network allows you to do. Polkadot is basically a network of connected blockchains. It allows you to connect all of these different kind of blockchains for interoperability, shared security, and many other features. Now, let me give you an example on how that even makes sense. So think of an application which is a logistics or supply chain related application. It will have some users who are going to basically act as a vendor, providing some service or goods to the manufacturer or someone who's buying those goods. And then there are people who are providing the logistics from moving these goods from one place to the other. Then there could be some other people involved who are doing the verification and checks and so on. So there are multiple parties involved, and they are providing a service or a good. This is a whole ecosystem where in a supply chain, you either provide a service or you provide some goods. But there is no free lunch, so everybody must get paid for what they are providing. So when there are so many parties involving and connecting with each other, they also get paid. So you have one, in the whole supply chain thing, you need a blockchain for logistics, you need at least a blockchain for payments, and you need at least a blockchain for identity, so that you can identify everyone, you can take their services, and you can pay them. How do you connect all of those chains together? Because if you put all of those things on one chain, you are going back to the problem of smart contracts, and nothing is optimized. But you are putting them on different chains, how do you connect them? How does your application work? That is what Polkadot allows you to do. It connects all of these different kind of blockchains in a fully decentralized and trustless manner, and your applications can be completely decentralized while being highly optimized. So that is where we started from a problem where we wanted to optimize blockchains for different kind of use cases. But once we built them all, we wanted to connect them so that all of these blockchains are able to talk to each other, providing you much better user experience and control on the things. So that is where we are coming back to summing it all together, where we say we want fast blockchains. We want blockchains that can be provided to the user on a quick and fast turnaround. We need optimized blockchains so that all of the users or all of the use cases can utilize the technology in a much better and optimized manner. And finally, we need connected blockchains so that these are all able to talk to each other and users don't have to worry about going from one blockchain to the other, having tokens about these different kind of blockchains and so on. Or even the application developers don't have to worry about that. So this is where what we provide at Parity and Polkadot is a framework called Substrate, which allows you to build different blockchains, and a protocol called Polkadot, which connects all those blockchains together. Now, I think I have covered most of the content here. So if you have any questions, feel free.
I can jump on stage now. So far, we are going to have 2 questions, and maybe some few are coming. One is, how much trust competence are you required to build a custom substrate chain?
So basically, if you are getting started in the blockchain space, you might want to compare with how you build Solidity smart contracts. If you know how to build a smart contract, you pretty much already know how to build a substrate chain as well. All you have to do is change the language a little bit. In there, we use Solidity. In Substrate, we use Rust. But the core fundamentals about decentralization, security, and blockchain-related stuff stay the same. So it does not require you to do a lot of stuff to build a custom substrate chain. It is as simple as building a Rust program, basically.
And the next question that we had, it was, can this be done on layer 2?
So basically, all blockchains that you build using Substrate are layer 1 blockchains. They are all connected with Polkadot, which is a layer 0 blockchain in itself. And then you can add more layer 2 related stuff on top of the layer 1s that you want to build. But most of the time in the Polkadot ecosystem and the Polkadot side of things, you do not require layer 2s because the layer 1s are much more highly optimized in nature. So this is actually, I want to tie this question back to the initial point. You need layer 2s because you cannot optimize these smart contract platforms. When you have already optimized them, when you are coming to Substrate, you might not require layer 2s so much.
We got one more question. Since you use Polkadot as a multi-chain connector, doesn't it make you dependent on Polkadot ecosystem?
It is a fully decentralized network. It does not make you dependent on anything. It basically allows you to connect everything in a fully trustless and decentralized manner. And then you do not have to depend on one single party or one single organization here because it is a completely decentralized network.
Questions are keeping on coming. What is the difference between Polkadot and Atom?
So basically, Atom is basically the token name for a different ecosystem or a different protocol called Cosmos. They are fundamentally very different things in nature. Polkadot provides you a lot of things like shared security and interoperability and a full SDK. Cosmos, on the other hand, also provides you to build custom blockchains, but it does not provide you shared security and interoperability on that level. So that is basically, you can say, the difference, that Polkadot has more features.
Sophie is asking, is there a real-life use cases for your blockchain platform?
Yes, I think I just mentioned one of the use cases about supply chain. So you have these different parties who are providing goods and services, and you have to pay them using different blockchains. So that is a real use case being built inside the Polkadot ecosystem right now.
OK, I think we don't have any other questions so far. We still have some time. If you want to ask some question.
Awesome. I think it has been a long day for all of you, so let's wrap it up here. One quick announcement. Do I still have the slides here?
I don't know. The slides are...
Can I have the slides back, please?
The slides.
OK, it's OK. So we have a workshop about how to build these custom blockchains tomorrow at 2 p.m. in workshop WS2. And you should be able to attend that. Yes, there it is. Workshop M2, 2 p.m. You will get to learn about how to build a custom blockchain using Substrate from scratch, and the story continues forward. Awesome. Thank you, everyone. Have a nice evening.